Assalamualaikum and hi. So for today, we're going to continue chapter 4, which is applications of differentiation. Previous week, we have covered chapter 3, which is differentiation. So for this week, let's see the application of differentiation. So this are the outline for this chapter. The first subtopic will be tangent and normal equation. The second subtopic will be extremum problem, which will cover extrema on an interval, the first derivative test, where you can see or you can determine whether the function is increasing or decreasing. And then we're going to have a look on the concavity and the point of inflection. This is quite new for you. And also relative extremum, but this one is going to we're going to use the second derivative test, which means you're going to differentiate it the function twice. And in extremum problem also we will have optimization problem. Okay, and for the third subtopic we will cover curve sketching, how are you going to sketch your graph or sketch your curve. And then the last one will be rate of change, kadar pertukaran. Okay. So let's for this week we'll only cover the first one, tangent and normal. Okay. And also extremum problem. So let's see the first subtopic, which is tangent and normal equation, persamaan tangent dan normal. So by the end of this subtopic, you should be able to find the equation of tangent and also equation of normal to a curve. Okay, so there will be two types of equations, tangent and also normal. So the first one, f prime x equal to dy dx. This is quite similar from what we have learned before, is also known as the gradient to the function of y equal to fx. Okay, remember dy dx or f prime x is also known as gradient. At point x1, y1 on the curve y equal to fx, the equation of tangent is y minus y1 equal to m1 x minus x1, where m1 here is the gradient, or we derive it as dy over dx. Okay, so where this one is the gradient of the tangent to the curve at the point x1, y1, which means when you have a point there, one point, and you have the gradient, now you can obtain the equation of tangent. Equation of tangent, the formula is given like this. Okay, to see it more clearly, this is a curve y equal to fx, so the tangent will be a straight line over here. Okay, this is the tangent, and the normal line will be perpendicular or 90 degrees from the tangent. Dia berlawanan. Kalau tangent adalah yang ini, then the normal will be the 90 degrees from that tangent. Okay, dia adalah berserenjang dengan tangent itu. So this is how it looks like in your graph. So remember, this is tangent, this is normal. For example, find the tangent and normal equation to the curve y equal to 2x squared plus 3 at x equal to 2. So you need to find the equation of tangent as well as the equation of normal for this curve at the point x equal to 2. So what happens is that you are given x equal to 2. Okay, you don't but you still don't have the gradient. So how do you find the gradient? Is that from this function y equal to 2x squared plus 3, we're going to differentiate it so that you have dy over dx, or also known as the gradient. So when you differentiate this, 2x squared, you get 4x. You differentiate 3, you get 0. So this is your gradient. So the gradient for tangent at x equal to 2, since it's already given the x equal to 2, why don't you substitute the value of x equal to 2 into this dy over dx, which means that you have previously you have dy over dx equal to 4x. Now it's mentioned that the tangent at x equal to 2. So you have to substitute the x equal to 2, then you get this is the gradient for the tangent, which is equal to at. Okay, so now can you find or can you derive your equation? Yes, because you already have x equal to 2, which means that you're going to find what is the value for your y. Okay, so your y will be, you just substitute the value. Just now you have y squared plus 3, right? So y squared plus 3, you just substitute the x in equal to 2 into the equation. Then you get the y value equal to 11. So the point just now, the incomplete point just now, you only have x equal to 2. Now you already found the y, which is the y equal to 11. So by using this formula, you can obtain your tangent equation. So y minus y1, y1 meaning that the point over here, this is your y1. Okay, so this is your x1, this is your x1, this will be your y1. Okay, so you just substitute the value into this formula, y minus y1, which is equal to 11. Your m1 will be the one you find, this one. This is your m1. Okay, I'm sorry. Where's the right? Okay. So this will be your m1. Okay, so you just substitute your m1 equal to at x minus x1. x1 will be this 2. So you just substitute, then you get this answer. So this will be your tangent equation. Okay, then you have to find another one, which is the normal equation. But you know that tangent is perpendicular to normal. How do we know this? Is from this one. Okay, dia kata dia perpendicular. This is your tangent, this is your normal, kan? Dia berserenjang. So what happened is that m1 times m2 equal to -1. We have this formula. Okay, kalau you have ada two straight lines, yang satu perpendicular to the other, so you have to use this one. m1 is the one you get just now, which is equal to 8. This is m1 is for gradient for tangent. This is gradient for normal. This one is gradient for normal. Okay, gradient for normal. Okay, so you just substitute the value you have at 8, and then m2 equal to -1. Then you get m2 equal to -1 over 8. So this is your gradient for normal. Just now you have, this one is gradient for tangent. Okay, now you have gradient for normal. So again, you're going to use this formula, but then you're going to substitute it with this one. Okay, so you have this one, x1 and y1, right? So for this time, you're going to substitute it with m2 lah. Okay, this one. It's not like m1, sorry. It's going to be m2. So your m2 will be this one. So you just substitute y minus 11, still using the same. This one is x1, y1. We're still using the same point. And the only thing different is the gradient. The gradient is you have m normal. Okay, you just substitute into this, then you get this answer. Whether you want to write leave it like this, or you want to rearrange it in terms of y equal to -1 over 8x plus 90 over 8 also can. Okay, so this will be your normal equation. Okay, so when we sketch our curve, our graph, it's gonna looks like this. So this is your curve, y equal to 2x squared plus 3, and then you will have a tangent line. Tangent ni dia bersebelah je dengan the curve, and then the normal will be 90 degrees to the tangent. So you just this is your graph. This is the equation of tangent, and this is the equation for normal. I think that's it for equation for tangent, equation of tangent, and equation of normal. Okay, next subtopic will be the extremum problem. In extremum problem, we're going to see a lots of other subtopics, which is like the first derivative test, second derivative test, inflection point, so on and so forth. But first, let's see the first one, the objective. At the end of this subtopic, you're going to determine the interval where function increases and decreases. Okay, you're going to see the interval and then discuss the first derivative test and find the relative extremum using the first derivative test. So we're going to see what is first derivative test. Okay. But fun fact, let's see the fun fact. I'm sure most of you have read this one. What is this? This is actually a roller coaster. So how do have you ever think how do they design roller coaster? Okay, how do they figure out the shapes? How do they know how steep to make the angles and how do them know how fast it will go? So the answer is, of course, they are using application of differentiation. Okay, so all this angle, the how fast it will go, how steep this what we call this the roller coaster punya line ni kan. So they are using application of differentiation. So nanti kita akan tengok how actually they use this thing. Okay. So the first one will be the extremum problem. So in extremum problem, you're going to learn the first thing you need to know is what is critical value and critical point and also stationary point. So these are the very familiar terms in extremum problem. So you need to know this one first. So what is critical value and critical point? Okay, any value of x equal to c in the domain of f at which f prime c equal to 0 or f prime c is not defined is critical value. Okay, dia kata dekat sini, if you have any value x equal to c, yang mana c ni any constant, in the domain of f, yang mana kalau you differentiate that f function, you substitute dengan the value c, you will get 0. Ataupun the derivative is not defined. That one you will call the c as critical value. Okay. And then you will have a point where the point contains c coordinate and also fc. Okay, this is x coordinate, this is y, this is x coordinate, this will be y coordinate. So this one we call it as critical point because it become a point already. Just now we only have x equal to c, x equal to c. Dia cuma dalam bentuk value x equal to c where c is a constant. But then when you have a point, satu point lengkap, you call it as critical point because you have point x, coordinate x and coordinate y. Okay. So that is critical value and critical point. Remember critical value mean bila you first differentiate dia, you substitute the value with c, yang mana c tu adalah constant, you will get the first derivative, you get 0, equal to 0. And the f prime c is not defined. Oh lah, either one. Okay, that one is critical value. Okay, how about stationary point? Okay, stationary point is a point where f prime c equal to 0. So, dia related lah dengan yang atas ni tadi. Kalau yang di atas ni critical value x equal to c bila mana f prime c equal to 0. But stationary point mean a point bila f prime c equal to 0. So, they're quite related, these three. Critical value, critical point, and also stationary point. Okay. Stationary point meaning dia tidak bergerak. Kalau if you have learned physics before, stationary mean dia dia tidak bergerak. Okay, so dia berada, dia punya first derivative tu equal to 0. Okay. Okay. Let's see over here. Okay, for f prime x equal to 0, so you're going to see over here, for example, this curve or this graph, this curve you have over here. So this is where the C or the critical value lays, okay, or the critical value or the critical points. Okay, this is the C. Okay, because critical value is x equal to C. Dia adalah koordinat paksi X. Okay, that's why dekat sini. Dia jatuh dekat sini semua. Koordinat paksi X. Okay, and this will be your critical point. This will be your critical point. Okay, critical point. Okay. This, I'm sure you know. This will be your critical point. This will be your critical values. Okay, and this also will be your stationary point yang tidak bergerak, dia di situ. Okay, as well as for this one, this will be the critical value, and this one over here. Okay, but for f prime x is undefined, that one is for f prime x equal to 0. But when f prime x is undefined, you will have a graph looks like this. Undefined maksudnya dia di tengah-tengah sini, somewhere yang mana this graph is not connected. For example, this one pula dekat sini. Dia tidak ada, to be exact lah, yang it's quite different from what you have previously. Macam ni kan? And also like this. Okay, so this is the example of f prime x equal to 0, and this is f prime x where it is undefined. So let's see the first example. Find the critical value. Find the critical values, meaning there will be more than one, and also critical points for the function, this one. Okay, so how do you find critical values? Remember, you're going to use first derivative macam ni. You kena differentiate this sekali. F prime x, from here you have fx, so f prime x, you differentiate lah this one. When you differentiate to x cubed, you get 6x squared. You differentiate x squared, you get 2x. Differentiate 20x, you get 20. Differentiate 5, you get 0. So you get this one. But remember, critical values, dia kata tadi, it must be the f prime x equal to 0 or undefined, right? So now when f prime x equal to 0, kita samakan dia dengan 0. This whole thing, you just write it back, you equal it to 0. So it's either you factorize it like this, or you just key in into your calculator so that you can get straight away the answer for x, right? If you key in into the calculator, you will get straight away the answer for x. The first x will be x equal to 5/3, and the second one will be x equal to -2. So this will be your critical values. Remember, I mentioned just now, critical values must be x values, okay? That's why you have x values only over there. And how about critical points? Critical points mean you have to find the y coordinate. You only have x, right, over here. So you need to find y coordinate for this, for each of these. So how do we find the y coordinate? You're going to substitute this one, this x, into the original function, this one. Not the derivative one. You're going to substitute this x into this, the original, so that you can find your y value. Okay. Okay. Then for the critical point, I leave it to you how you're going to find it. Your x1 and y1. The other one will be x2 and the y2. Which is this one. Oops. So I leave it to you to try. And y2. Okay. Just substitute this one and this one. Substitute into where to find y? Substitute into the original fx, not this one. Okay, so you will get a point there, 2 points. Yeah, then you're going to please try this, the exercise. Okay, find the critical values or value. Sometimes dia cuma ada satu, sometimes you will have more than one. And the critical point for the following questions. Okay, so you have critical value for x and point, meaning you have to substitute the x that you get into the function to get the y value. So you will get the complete point. So I give the answer already. Please try it. So check whether you get the same answer or not. Okay. And then, okay, let's check for the function increases and decreases. How are we going to check, or how are we going to determine whether the function increase or decrease? Okay, let's see the definition first. Definition and theorem. F is increasing in interval L in interval I think, if fx1 less than fx2, and second one f prime x greater than 0. Okay, dia kata graph tu berdasarkan graph, you will know that the graph is actually increasing when you have fx1 less than fx2. That means that this one is fx1, this one is fx2. Yang mana yang fx1 tu value dia lagi rendah daripada yang fx2. Maksudnya daripada kecil naik kepada yang besar. That one is increasing. And lagi satu cara untuk detect is f prime x must be greater than 0. Bila you differentiate, you first differentiate that the function, you will get it greater than 0. That means that it is increasing. Okay. And for the decreasing, how you going to check or determine it is this one, fx1 greater than fx2. See, fx1 dia lagi besar daripada fx2, yang mana obviously the graph is decreasing. Dia menurun, berkurang. Okay, and also the first derivative of the function less than 0. Okay, dia berkurang, so dia less than 0. Just now you have greater than 0 when it is increased. Okay, then this is when f is a constant. Kalau dia constant, meaning dia tidak bergerak. Macam ni lah, you have this kind of graph, static. Dia tidak turun, tidak naik. It's neither decrease nor increase. So you have fx1 equal to fx2 and the first derivative equal to 0. Okay, so you have 3 cases: increase, decrease, and also constant. But for the constant, we're not going to focus on constant. Okay, we're going to see on decrease and increase. Okay, term of a function. Okay, term of a function kata dekat situ. F is defined in interval L and continuous in A, B. x1 and x2 are the values in interval I think this one is I, with x1 less than x2. Okay, then for interval determination, how we going to determine our interval? Kita punya interval, kita punya selang tu kita mau tentukan. So there will be 4 steps. The first step is we're going to determine the domain first, the domain for fx. Okay, so domain mean x value from what we have learned in the first chapter. Okay, step 2, you're going to determine the interval to test. So this one from here, you're going to determine the interval. Step 3, test the f prime x sign that determined in S2. And step 4, you're going to make conclusion. Okay, remember we have 4 steps. First, you need to find the domain and then determine the interval and then check for the f prime x sign, and lastly, you're going to make a conclusion. So let's see how we're going to apply the 4 steps just now. Example 2, determine the interval of fx, where the fx is given this, which the function are increasing or decreasing. So dekat sini, dia minta kamu tentukan based on this function, di mana function tu increase dan di mana dia decrease. So dalam function ni, dia ada dua-dua. Dalam this function or this graph later on we will sketch di mana dia increase, di mana dia decrease. Okay, so the first step, remember, we need to find the domain of the function. So the domain you can see over here, it will be negative infinity until positive infinity. So this is what you have learned in chapter 1, right? The domain and range. And then second step, you need to determine the interval by critical value. So how are you going to determine the interval? Using the critical value, where critical value means, remember, critical value means you need to equal it to 0. This one, right? Okay, this one. So first, from the fx, you need to differentiate it. First, differentiate this one. So you get 4x cubed minus 4x. Then you equal it to 0. The first derivative, equal it to 0, so that you get like this, f equal to 0. Then you're going to factorize it. Either you want to factorize, or you can straight away key in into your calculator so that you get the critical values. So the critical values will be these three: 1, 2, and 3. Okay. So when you have critical values, of course you will have critical points, right? Okay, don't worry about that. So, tengok dekat sini. We have critical, we already in step 2. Now we're going to move on to step 3. Okay, so you obtain already your x value or the critical values. Okay, what happened is that your critical values, remember. So the third step mentioned that you need to test the fx sign. Okay, you need to test the fx sign, but you already found this one. You're going to determine your interval. So you already x equal to 0, x equal to 1, and x equal to negative 1. Sekarang kita akan tentukan kita punya interval. So kita punya interval, tadi kita dah tahu kita punya critical value. The smallest one will be negative 1. So then kita ada 0, then kita ada 1. Okay, we refer back to our first step, which is the first step, kita tentukan dia punya domain, right? The domain will start from paling kecil will be negative infinity. So we will have negative infinity until negative 1. Why is it until negative 1? Because dekat sini. Okay, then we close the bracket. So we already obtained one interval. Satu selang kita dah dapat. Then the second interval will be, again, kita start daripada negative 1. Tadi kita dah stop dekat negative 1. Again, kita start again with negative 1 until 0. Kita sambung lah. Daripada negative 1 until 0. Okay, close bracket. So you already have two intervals. The third intervals will start again with the one you finished tadi. You dah stop dekat sini 0. So you start again with 0. Now 0 until 1. Why is it 1? Because you already have this one. Okay, over here. They stop dekat 1. Not 2, not 3, not 4, not 5. It has to be 1. Why is it 1? Because you have this one. And why is it 0? Because you have this one. Why is it negative 1? Because you have this one. So you close bracket. Then the last interval will be from 1. You dah stop dekat 1, you start balik from 1. And yang paling biggest is infinity. Sebab you refer balik you punya domain dekat sini. Domain paling kecil, negative infinity. Paling besar akan stop dekat positive infinity. So now you already obtain your 4 intervals. You have 4 intervals, right? Okay, listen carefully. Now you already obtained your 4 intervals. You need to find value of x. For example, dekat sini, for value of x over here, you can choose any value as long as the value of x is within this interval. For example, I chose -2. Since -2 is within this interval, you can also choose -5, -10, -100 also can. Okay, boleh. As long as dia berada dalam sini. Okay. Then for the second one, I choose -0.5 since it's within this range. Okay, dia di antara, dia masih di dalam this interval. As long as this one, okay, I choose 0.5. It's up to you whether you want to use 0.5 or you want to choose 0.1 also can. Okay, and then for here, I chose 2. Okay. You can choose 3, 4, 5, so on and so forth. Okay. Okay, this is just a matter of value of x. Why do I need to choose the value of x? Because I need to substitute this value into the f prime x just now. So over here I have this table, okay? I have this table. So sine of f prime x. Sine of f prime x mean, where is my f prime x? This one. You going to substitute, macam mana you mau cari dia punya sign, whether you will have positive or negative number, is that this -2, I'm going to substitute into this f prime x. For example, I substitute f prime 2, -2, right? I just substitute -2. Ganti masuk. What did you get? You ganti masuk ni. 4x cubed, I substitute -2 minus 4 -2. Okay, so I get -24. The answer is -24. Forgive me if I'm wrong, but the answer is negative. Okay, see, the answer is negative. So the sign over here is negative. That's why I just put it negative. And then as same for this one, I just substitute 4 times -0.5 cube minus 4 times 0.5. So I will get the answer positive. You key in lah guna calculator. You get whether you get the answer positive or negative. We don't want the value. We just want the sign, whether it is positive or negative. That is important. Okay. Kita tidak pentingkan dia punya value. Whatever the value, it's up. We just leave it. We just want to know whether it is positive or negative. So when I substitute this -0.5 dalam ni, you will get the answer positive. And then sama juga untuk yang ni. How do I find the f prime x value, dia punya sign? I substitute the 0.5 into this. Ganti masuk ni dalam sini. Sama juga, ini ganti masuk 2 ni dalam f prime x ni. So you get net positive. Okay, now the last step will be you're going to do the conclusion. Okay, the conclusion. The last step, which is the fourth step. So what we have is here over here, the sign from what you have, the sign f prime x. This one is negative, right? Negative mean it is decreasing. You have something like this. The curve look like this, decrease. And this one you have increase, like this. This one again decrease. This one again increase, kan? So bila you lukis your graph, it's kind of like this. Decrease, increase, decrease, increase. Like it's kind of like this lah. It's kind of like this. Macam ni lebih kurang. Okay, bila you lukis your graph. Decrease, increase, decrease, increase. Ataupun in smooth way. Macam mana? Macam ni lah. Maybe in a smooth way. Decrease, increase, decrease, increase. It's maybe like this. Okay, so the conclusion, you can say that since dia soalan tadi tanya dekat mana the function increase and in which interval the function increase and in which interval the function decrease. So now you already know it. The negative one until negative infinity until negative 1, and this one 0 until 1 are decreasing interval here, decreasing interval. And for this one, negative 1, okay, sorry, where is my cursor? Okay, negative 1 till 0 and 1 until infinity, this is increasing interval. So this is the conclusion. Okay, I hope you manage to understand, even though there's lots of steps you need to do. There are 4 steps. First one, you define define your domain. Second step, you find your critical values. Where over here I have 3 critical values, and then I create my interval based on my critical values over here. Then I choose value of x, any value of x as long as dia berada dalam this range, and then I substitute the value of x into the f prime x so that I get the sign, sama ada dia positive or negative. So based on the sign, I can make my conclusion. Kalau negative, dia decrease. Kalau positive, it is increasing. So you need to state lah in words macam ni. Okay. So this is how you determine your increasing and decreasing interval. Okay, let's see the next example. Okay, the third example. Find the relative extremum of fx given this. Okay, so you have this function. First you need to do is to find the critical value of x. Remember, always find the critical value. Critical value means the x value. Okay, so how do you find critical value? You differentiate it first. Differentiate dia dulu. Then you equal it to 0. You already found this one, the first derivative. Then you equal it to 0. Then you get your x equal to 4. Also, f prime x does not exist when x equal to 0. So, dia ada 2. So, the critical values will be x equal to 4 and also x equal to 0. Okay. So, based on this, how do I get my critical value x equal to 4? From here, x minus 4. So, x equal to 4. How do I get x equal to 0? This one. X equal to 0. Sebab dia ada bahagi kan dekat situ. So, dekat bawah ni cannot be 0. I'm sorry. You cannot have 0 down here. Otherwise, you will get the function undefined, kan? So, from here. Dia tidak boleh sama dengan 0. Kalau you ganti dekat bawah ni 0, anything you divide by 0, it is undefined, okay? That's why you have the critical values 4 and 0. Okay, now you have your critical value 4 and 0. You need to determine the maximum or minimum. We set the following chart. Sama juga table macam tadi lah, or chart kan. So the first interval, we have 4 and 0. The first interval, remember, it always start with negative infinity kan. Negative infinity until 0. How do I get 0? From here lah. And then the second one, you start again with 0 until 4. And then the last one, 4, you start back daripada 4 until infinity. So you will only have 3 intervals. Ada 3 sahaja. Now you need to pick any value of x as long as the x di dalam ni, di dalam this interval. Mana-manalah, apa-apa sahaja. So dekat sini I choose negative 1, dekat sini I choose 1, dekat sini I choose 5. Jangan pula pilih nombor yang complicated lah. Jangan pilihlah nombor bulat so that it's easier for you to calculate kan. And then again I substitute this value negative 1 into the f prime x. Mana f prime x saya tadi? This one. This is the f prime x kan? You already found it. You ganti masuklah tadi yang you dapat negative 1 semua tu 5 semua tu ganti dalam f prime x. Ganti masuk this whole thing. Negative 1, 1 and 5 ni ganti masuk. Ni ganti masuk dalam f prime x. Prime x. Okay. You ganti masuk. So you get this sign lah. You get positive. This one you get negative. This one you get positive. Kalau tidak percaya, you just try calculate by yourself. Then from here you have positive, negative, and positive. You can make conclusion. If positive, it will be increasing. Negative, it will be decreasing, and also increasing. So the graphs look like this: increase, decrease, and increase. Okay. Okay. So when x equal to 0, then f prime, ini maksud dia cari y dia. Dia cari y value. This are all y values. Values dia kan. So bila you ada x equal to 0, you carilah what is your y values. You substitute the x equal to 0 into the f, the original f. Bukan substitute dalam f prime. Substitute dalam f prime tu untuk you cari sign je, whether it is positive or negative. To find the y value, you need to substitute into the original function. Okay. Then when x equal to 4, you substitute lah. X equal to 4, substitute dalam this function. The original one, this one. So you get the answer like this. Therefore, dia katalah that from here you already obtain 0, 0, and this one 4, negative 11.3. So therefore 0, 0 is maximum point, and this one will be the minimum point. How do I know it is maximum and minimum? Because you tengok you punya graph dekat sini kan, increase, decrease, increase. Satu dekat sini, point tu satu dekat sini, satu lagi dekat sini. Meaning that this one is maximum point. This is maximum point. This is minimum point. So maximum point will be 0, 0. Minimum point yang ada ni, ada negatif ni. Sebab ini start daripada 4 kan? Dia punya x value 4. Maksudnya dia dekat sini. Yang ini minimum. Yang ini 0, 0. Dia dekat depan sini. Okay. So this is how you find your maximum and minimum point. And also your increasing or decreasing interval. Okay. Then these are some exercises for you. Please try it. I already provide the answer. Check whether you get the similar answer or not. Sorry. And next, we're going to see the first derivative test. We already know how to find the increasing or decreasing interval. We already know how to find minimum and maximum point. That one is extremum lah. Extremum. And then now we're going to see the first derivative test. Apa tu first derivative test? Okay, suppose that C is a critical number. Dia kata C is a critical number of a function f that is continuous on AB. If f prime x greater than 0, kalau apa jadi kita kata tadi, kalau f prime x greater than 0, meaning that is increasing, right? Kalau f prime x less than 0, dia decrease. Okay, so dia kata lagi f prime x less than 0 for this CB, then f has a relative maximum. Okay, this one is relative minimum. And kalau dia tidak change sign dia tu tidak berubah, no relative extremum. Okay, ni kita akan tengok dia punya contoh. I'm sure you still a bit blur from these words, from this sentence. Let's see the. Okay, this is actually the easy way to remember the first derivative test by visualizing diagram. Sebab tadi tu dalam bentuk sentence. Okay, yang ni in sentence kan, dalam bentuk ayat. So it's quite difficult for you to memorize. So I provide something which is using graph like this. So this one is relative maximum. Kalau you ada satu curve macam ni, sebelah sini greater than 0. Remember kalau greater than 0 dia increase. Kalau less than 0 dia decrease. You have like this relative maximum. Relative maximum you mean you have maximum point dekat sini. This one will be relative minimum. because you will have critical minimum point dekat bawah sini. Ni minimum point, ni maximum point. Ni maximum. This one minimum. Okay. And kalau dekat sini, not extremum. Kita tidak tahu di mana dia maximum, mana dia minimum, right? For this one, dia tidak ada puncak dekat situ. Tidak ada puncak. Okay, not extremum for this kind of graph. Okay, so this is actually what does it mean by the previous sentence yang panjang-panjang tu lah. Okay, let's see the example. Find the maximum or minimum values of the function. Okay, given that the function is this, quite long. Okay, so find maximum or minimum values of the function. So what you need to do first is you're going to differentiate the function. So you have dy over dx. Remember, why do I need to differentiate? Because I need to find the critical values, right? Critical numbers or critical values. Then I set this dy over dx equal to 0. Samakan dia dengan 0. Again, I get my x values. Critical numbers ni maksudnya critical values lah. X there. 1 over 2 or negative 3. Okay. Then what happened is that I already found my dah dapat kan? Dah dapat my what did we call that? Net critical values. So you need to create your interval. So what happened is that the first interval start with negative infinity until negative 3. Then negative 3 start balik negative 3 until half. And then close. Start balik half until infinity. You just bermain dengan number ni saja. These two. To create the interval. Okay. Okay, then I pick any value of x yang berada dalam this interval. Pilihlah apa-apa value sahaja yang selagi dia masih di dalam this range, this value, interval. Then I get bila I dah dapat x value, I substitute it into the f prime x, the first derivative tadi. Ganti masuk 4 ni dalam the first derivative, I get positive sign, negative, and positive sign. So, conclusion, this is increasing, this is decreasing, this is again increasing. So, you already found your dy over dx, which is this. Bila you ganti x equal to negative 4, you get this. Okay. Sorry. Let me see first. Okay. Okay, you can see from the chart that dy dx changes from positive to negative at x equal to negative 3. Kita tengok dia berubah kan daripada ni, mulanya dia positif dan dia negatif. Dia macam ni lah, lebih kurang graf dia. Naik, turun, naik semula. Yang dia berubah ni dekat sini ni, dia 3, negative 3. Yang dekat sini pula adalah half. Dia increase and then dia increase balik dekat sini half. Okay. So, yang ni dia just substitute x equal to negative 4. I pick any value lah, x equal to negative 4. I just substitute into the f prime x, where I get the answer is this one, 54. Sorry, this one should be negative, okay? Not positive. Sebab negative 4 ni dia dalam sign ni. Masih dalam this interval. Bukan 4 My mistake just now. It should be negative 4. So, this is how I obtain this one. Okay. How do I obtain the positive one? This one is positive. From here. Macam mana dapat positif? Daripada ni lah cara kira dia. Okay. Sama juga untuk yang lain. You just substitute dalam the dy dx, the f prime x. Okay, so by the first derivative, dia kata by the first derivative test, f has a maximum at x equal to negative 3. Betul yang tadi kita tulis kan? Ni negative 3. This one is half, right? So the maximum dekat sini, -3. And the local maximum value is, macam mana cari local maximum value ni? You substitute lah yang -3 ni tadi dalam the original y so that you get your y. Okay, since f prime x changes from negative to positive at x equal to half, dia cakap dia berubah daripada negatif dia pergi positif dekat x equal to half, so f has a minimum at x equal to half. Dia minimum dekat sini. Tengok dalam, kalau you tengok daripada graf ini pun you dah boleh start sketching. So ni increase, ni decrease, ni increase. Bila you sambung dia jadi macam ni. Okay. So you tahulah di mana yang maximum tu dekat 3 sini. Mana yang minimum tu dekat half sini. Okay. So you need to find the local minimum value. Local maximum value meaning you have to substitute the x into the y. So that you have this one. Local minimum sama juga. Cuma nama dia saja berubah. Tadi maximum, sekarang minimum. You substitute the value of half into the y, the original y. Okay. So that you get this answer. Okay, that's it. You already found your local maximum value or local minimum value. Okay. So these are some exercises for you. And the last one will be the concavity and the point of inflection. Okay. For this part, the concavity and the point of inflection. What is concavity? Kan kalau kita belajar fizik, we have learned concave. Concave kan macam yang kanta tu, the lens. You have concave and the other one. Okay. So concave and convex, right? If you learn physics, concave and convex. Kata cekung, kata capah, is it? So it's quite similar to this, the concavity and the point of inflection. Okay, what does it mean by point of inflection? Is that point, titik di mana dia mula berubah. Point of inflection, titik di mana dia mula berubah lah. For example, dia macam ni kan. Dekat mana dia mula berubah? Dekat sini. Dia mula-mula dia increase, turun, lepas tu dia start like balik. That one is point of inflection. So for point of inflection, how do you find point of inflection? Kita kena cari second derivative dia. And then you equal it to 0. With a change of sign in the value of f prime x for the interval before and after the expected point of interval. Change of sign. Di mana dia mula berubah. Cumanya kalau tadi critical point, you need to find the first derivative, equal it to 0. But now it is point of inflection. Remember kalau inflection, you kena differentiate 2 kali. Second derivative. Then you equal it to 0. Okay, for example, we have this function. Find the inflection point and determine the interval where fx is concave upwards and concave downward. So to find inflection point, you differentiate 2 kali lah. You differentiate sekali, this one, you differentiate sekali, you get 3x square. You differentiate lagi kali kedua, you get this one. You equal it to 0. Then you get your x equal to 2. Satu sahaja. Usually kalau inflection point ni, dia satu sahaja. Okay, sebab you dah differentiate 2 kali, so the x value getting smaller lah. The x punya option tinggal satu saja. So when you get x equal to 2, your y equal to 4. How do I get this one? Y equal to 4. I substitute this one into this. Substitute dalam fx so that you get this. Okay, so the inflection point is 2, 4. That's it. Okay, senang saja inflection point. But yang susahnya tu, bukan susah, dia remeh sikit, it's a bit tedious. Because you need to find the interval. You see the equation, you need to find the interval where fx is concave upward or concave downward. Yang tu yang leceh. Okay, untuk cari inflection point senang saja macam ni saja. So sama jugalah macam tadi. So you have your point since you only have 2 kan, dekat sini x equal to 2, satu saja value. So your interval you will have like this lah. Satu dia macam ni, satu greater than 2. Senang saja. Okay. Dan ni contohnya macam ni lah, lebih kurang negative infinity until 2. Then this one 2 until infinity. Lebih kurang lah tu sama je. It just I use it. I wrote it down in this form. X less than 2, x greater than 2. So then again, I pick any value of x within this range. Tidak semestinya you want to use decimal kan? Maybe you want to use 3 or 4. Maybe you want to use just 1 or 3 dekat sini. It's up to you. Then you substitute into f double prime. Tengok dekat sini f double prime. Kalau yang tadi, extremum problem yang tadi, you just cari dalam f prime. Ini f double prime. So, bila I ganti masuk, I get negative and positive. So, kalau negative meaning dia concave, downward. Kalau positif, dia concave upward. Macam tadi, kalau negatif, decrease. Positif, increase. Sekarang dia tidak guna perkataan increase or decrease. Dia guna concave downward or concave upward. That's the difference untuk inflection point. Okay. So, this is how you answer your question. Next example, given a function this, determine the point of inflection. Then second one, interval where they are concave upward and fx is where they concave downward. Sama juga lah. So, how do you find your point of inflection? You differentiate dia 2 kali. Differentiate sekali dapat ni, differentiate lagi sekali dapat ni. Then you equal it to 0. Samakan dia dengan 0 so that you get your point of x. Bila dapat x equal to 1, you substitute balik dalam this one, dalam original fx, so that you get y equal to 3. There. Then that is your point of inflection. Now you need to solve for the second one. You need to determine dekat mana dia concave upward, dekat mana dia concave downward. Again, you need to create your interval. Okay, since dia only you ada satu sahaja, so it's either less than 1 or satu 1 lagi greater than 1. Sama jugalah macam ni. Kalau you prefer to write it down in this form pun boleh. Or you want to write it down dalam yang kotak bawah tu pun boleh. It's up to you. Sama je sebenarnya. Okay. Then, pick any point or pick any value of x. Ganti masuk dalam the second derivative. You get positive or negative. Kalau positive, concave upward. Negative, concave downward. Okay. So, I think that is for the first part, which is we already cover what is tangent line, what is tangent equation, normal equation, the gradient, which is the gradient is dy over dx, and then we already know how to check where the function increase, where the function decrease using the first derivative test kan, you cari critical values, which means that the f prime x equal to 0, then you obtain your critical values. After that, you create your interval, cari any value x, substitute dalam f prime x. Okay, that one is critical value, maximum minimum point. But for inflection point, it's quite different. Remember, inflection point, it has to be second derivative. You can differentiate dia 2 kali, macam ni. Like this. Okay, differentiate sekali, differentiate lagi sekali. Then baru you ganti masuk the answer, you get the inflection point. Then to determine whether they're concave upwards or downwards, you just, again, you need to use this table lah.